decided. So here, so just kind of like some notes for the end. The final exam will be on Monday, May 10th, during class time. All right, so that's the last proctored exam we have. What? I don't think you're trying to talk. So we won't have class on the 12th. So we're done. The Monday, May 10th. That's it. And then the take-home test, right, is due this Wednesday, right? Yeah, May 10th isn't too far off, right? It's 4 weeks from today. So it's one more, I think, 4 weeks? Yeah. 1, 2...
Dr. Gorman?
Yeah.
Do you have office hours today?
I do. So I have office hours after our class. And so you just use the office hour link that's in Canvas.
Okay, yeah, because I just, didn't understand something on the test.
Yeah, so I was going to say, if anyone has questions about the test, I'm not going to answer them, generally here, but I will be happy to answer questions people have. So, and depending, we might have a little bit of time at the end of class, in which case you can stick around and ask a question at the end of class, too. Any other questions?
Yeah, I have a question.
Sure.
So when you're building the practice for the written response or the word problems and stuff, it doesn't matter how you draw your triangle or what points you label A, right?
Correct. Yep.
Okay, because it'll come out the same way.
Okay.
Thank you.
No problem. Okay, so I'm just gonna, since there's some feedback from you guys, so I'm just gonna mute everybody, and then if you need to ask a question, you can unmute yourself to ask it, so that's not a problem, or type it in the chat, either one. Any other questions? Okay, so questions about the take-home test, you have to, either stick around at the end of class to ask me, because I'll answer questions individually, or I'll at least tell you I can't answer that for you. So if you have questions about the take-home test, you can ask them later on. Other questions? No problem. So I'll end class a little bit early, because between what I have to do today and next class, there's not a ton of stuff. So we'll get through what we need to get through today, and then anything else we can do next class. So that way I can answer questions people have about the test. Okay, anything else? No? Okay, so then today we're going to look at section 7.4, which is vectors. So vectors are, if you have to go on and take Calc 3, that's when you'll encounter vectors again. So a little bit of the stuff that we're doing right now at the end of the semester is kind of setting up for future Calc classes. Right? We talked last time how the polar coordinates was stuff that you would see in a little bit of Calc 2 and Calc 3. Vectors is something that you would see in Calc 3. So the idea with a vector is it's a directed line segment. So a vector is a directed line segment. So maybe I have a vector, it's sitting here between these 2 points, and it starts at this bottom point and it goes up to the top point, right? So it's kind of like, you can think of it like a little arrow. That's all a vector is. The place where the vector starts, down here, this is called the initial point. And the place where the arrow is, that's called the terminal point. And we can think about going out some so our vector, so you could think about if you wanted to travel from this point here to this point here, you could go directly along the vector. The other way you could do it is you could travel in the x direction and then in the y direction. So I probably should have made this blue here. So the x direction is, you're moving some vector. So I is talking about the distance in the horizontal direction, and j is talking about the distance in the vertical direction. And let's give ourselves some letters for these points. Let's call this point P and point Q. So there's a couple ways that you could use, you could write the vector from P to Q. So you'll see it written sometimes with a little arrow over top PQ. So that's letting you know, oh, I have a vector between P and Q. Some books, some places will write the arrow, but they'll only kind of put one side of the arrow on it. It's just being lazy. But if you see that, some textbooks, when you look at vectors, they will make them bold, right? So it's really hard, obviously, for me to like write in boldface. But a vector can also be represented just by making it bold. Okay, so I'm not going to write bold when I'm doing it. I'm going to mostly do the double arrow. Sometimes I get lazy and I just do the single arrow. But that's the way that you're going to see vectors written. And vectors have an x component and this j component. So you can move in the I direction, so the x direction, and you can move in the j direction, which is the y direction, right? So the vector PQ here is equal to A, you see I already didn't write the full thing. So A times the vector I plus B times the vector j. Okay, so let's give these points. So let's call this point x1, comma y1, and let's call this second point x2, comma y2. So A is going to be the change in the distance in the x direction. So A is going to be x2 minus x1. B is going to be the change in the y, so y2 minus y1. And so we have it kind of written down. I is a vector of length 1 in the x direction. And j is a vector of length 1 in the y direction. We can also write the vector in what's called component form. So this part here, this is what's called IJ form, right? So you're talking about you have this, the I and the J. Whoops. We can also write the vector in what's known as component form. In component form, it looks kind of like an ordered pair, except it's going to be between these pointy brackets. So we could write it as A, comma B. This is what's called component form. So the beginning here of vectors is actually, it's not that hard. It's just a lot of different notation than what you're used to, right? So we can write it in the IJ form. We can write it in the component form. And it's basically, we're just changing, the X part is just the difference in the X's, and the Y part's just the difference in the Y's. Questions? Okay, so, does anybody need me to wait to go to the next page so I can do some examples so we can kind of see what we're dealing with? Sure, not a problem. Let me know when you're ready for me to move on. So, for example, a vector has initial point -3, -2, and terminal point -6, -1. Write the vector in vector v is equal to ai plus bj. Okay, so the problems are going to tell you to write it either in this ai plus bj form, or they're going to tell you to write it in component form. If it doesn't say, if it just says find the vector, then you could write it in whichever form you want. So, the initial point, that's going to be our x1 and our y1. So in this case, our x1 is -3, our y1 is -2. The 6 and the -1, that's going to be our x2 and our y2. So remember, a is equal to x2 minus x1. So in this case, that's going to be -6 minus -3. Or -6 plus 3, which is -3. And the b is y2 minus y1. So that's going to be -1 minus -2. So -1 plus 2, which is 1. So I found A, I found B. And so now all I have to say is, okay, my vector v here is equal to a, -3i, and then b is 1, so plus 1j. You don't have to write the 1, right? So you could write this as -3i plus j. So if the coefficient is a 1, you don't have to write the 1 in front of it. Questions? No? It's not too bad, right? Vectors is actually pretty easy. It's just a matter of like remembering what to do with them, but for the most part, vector stuff is not too hard. All right, so let's look at another one. So write the vector with initial point 2, -3, and terminal point -3, -4 in component form. So remember, component form is that pointy bracket A, comma, B, right? So again, we just have to find A and B. Again, the initial point is going to be your x1, y1, and your terminal point is going to be your x2, y2. So A is going to be -3 minus 2, or -5. And B is going to be -4 minus -3. So -4 plus 3, or -1. So our vector is going to be -5, comma, -1. Questions? No. It's not too bad, right? Okay. Does anyone need me to wait before I go to the next page? No? Okay. So now what we're going to do is we're going to look at all different things we can do with vectors. So operations on vectors. So one of the things that we can do is we can find the length of a vector. So the first thing is we can find the length of a vector. And that's called the magnitude. And the magnitude just really comes from the distance formula between 2 points, right? So if you think about it, I have here, here was this first point, x1, comma, y1. And here was the second point, x2, comma, y2. And I had this vector that went from the first point to the second point, right? So if you remember back to math 126, we can find the distance between 2 points. The distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. But in terms of vectors, x2 minus x1, that's just A, and y2 minus y1, that's just B. So for vectors, the magnitude, which we give a special symbol for, so the way we write it is a double line. So the magnitude of vector V is equal to the square root of A squared plus B squared. So, for example, find, the length / magnitude, right? You could use either word interchangeably, of A. Vector V is equal to 3I minus 3J. So the length of V is going to be the square root. So 3 is my A, right? This here is my A. -3 is my B. So it's going to be 3 squared plus -3 squared. So it's going to be the square root of 9 plus 9, or the square root of 18. And you can leave your answer as a square root of 18. You don't have to rationalize it. Or not rationalize it. You don't have to break down the root. You can and make it into 3 root 2, but you can just leave it as square root of 18. Questions? Sure. I'm not going to the next page anyway, but I do have another example I'm going to do on this page. But let me know when you're ready for it. No problem. Okay, so let's look at B. So B is the vector V is equal to -6, comma, -4. So this time it's written again in component form. So again, the first numbers just are A, the second numbers are B. We're looking for the length. So the length of vector V is going to just be the square root of -6 squared plus -4 squared. So it's going to be the square root of 36 plus 16, or the square root of 52. And again, you can just leave it as the square root of 52. You could break it down. If you broke it down, it'd be 2 root 13. But you can just leave it there. Questions? No? Okay, does anybody need me to wait before I go to the next page? No. Okay. All right, so here's another example. Vector V extends from 0, 0 to 3, 4, and vector W extends from -2, 3 to -5, -1. So this is a multi-part question. The first question is going to ask us to find vector V and vector W. And it didn't tell us whether we had to do it in the IJ form or whether we had to do it in component form. So when it doesn't ask us, I like to do it in component form just because it makes life a little easier. So vector V. So remember, here, this is my x1, y1, and this is my x2, y2. When I'm finding this, I don't always write out, here's what A is, here's what B is. Sometimes in the component form, I just do the subtraction right there. So remember, A is x2 minus x1. So it's going to be 3 minus 0, comma. B is y2 minus y1, 4 minus 0. So vector V here is just going to be 3, 4. Questions so far? No. Okay, vector W is going to be -5 minus -2, comma, -1 minus 3. So we're going to have -5 plus 2, comma, -4, or -3, comma, -4. Questions on W? No? Okay, part B, we're going to find the length of V and the length of W. So the length of V is going to be the square root of, so the A component squared, so 3 squared, plus the B component squared, 4 squared. So this is going to be the square root of 9 plus 16, so square root of 25, which is 5. Right, so if it's something easy, I'll break down the square root, right? Square root of 25 is easy. And the length of W is going to be the square root of -3 squared plus -4 squared, which is going to be the square root of 9 plus 16, which is the square root of 25, which is 5. Questions? No. Okay, so it's important to note here that even though the two vectors have the same length, so just kind of a little note, right? So both vectors have the same length. Oops. Both vectors have the same length, but they are not the same vector. Okay, so one of them, the components are positive. One of them, both components here are negative. For two vectors to be the same, they have to be exactly the same. The components have to be the same. So the A and the B between both vectors would have to be the same. But they are not the same vector. Questions? So yeah, so not a problem. So they're not the same vector because even though their length is the same, right? So it means they're both of the same length, how long the vector is. But if you look here, this one is a +3, +4. To be the same vector, it has to be +3, +4. Over here, I don't have +3, +4. I have -3, -4. Right? So to be the same vector, when I figured this out here, these would have to come out to be the exact same things as these. Does that make sense? So the length of two vectors is not always the same. If your numbers here are the same, just some are positive and some are negative, then yeah, the length will turn out to be the same. Does that make sense, Liana? No problem. Other questions? Okay. So, oops. So, given a vector v with initial point 17, 80 and terminal point -72, 53. The first part we're going to do here is find the component form of vector v. Okay, so just what we've been doing, right? So vector v is going to be, so the terminal, the x2, so -72 minus the beginning, -17, and then 53 minus 80. And so if we work that out, this should be -89, -27. Questions? Okay, so you can pick up, like, you can think of a vector. I could pick it up and I could move that vector around in space to wherever I wanted, right? So, like, maybe, you know, that vector v, right, was, you know, sitting over here, right? And maybe I want to pick it up and I want to move it to down here, right? So it's the exact same vector, but I've just picked it up and I've moved it. So that's what part B of this question talks about. Part B says if v is placed with initial point -13, -12, what is the new terminal point? Right. So I've taken the vector from part A, that component vector, and I've picked it up and now I've moved it so that the terminal point or the initial point is at -13, -12. So this is a little bit of a different problem. Remember, we still want the vector to be the same, right? So we still want v when we, whoops, I don't know why I made it a script v. We still want v when I figure out what the terminal point is. We still want it to turn out to be -89, -27. We don't want to change the vector. We just want to pick the vector up and move it. So remember, when we're doing this component form, right, which we know we want to be equal to -89, -27, remember the component form is A, B. And remember the A we get from x2 minus x1, and the B we get from y2 minus y1. And that x2 and y2 come from the terminal point, and x1 and y1 come from the initial point. And so in this problem, I don't know the terminal point, but I know the initial point. So this -13 is x1, and this -12 is y1. So I could plug those in here. So this would be x2 minus -13, y2, which I don't know, minus -12. And I want that to turn out to be -89, -27. Or in other words, x2 plus 13, y2 plus 12 has to be -89, -27. So I'm not done with the problem yet. I'm going to finish it here in a minute. But are there any questions on anything I've done on this part of the problem so far? No. Okay, one no. It's okay if you have a question, though, for anybody else. No. Okay, so now what I want to do is I basically want to match up those two pieces, right? I want x2 plus 13 to turn out to be negative 89. So if I subtract 13 from both sides, x2 is going to turn out to be negative 102. And I want y2 plus 12 to end up being negative 27. So if I subtract 12 from both sides, y2 is going to end up being negative 39. So my terminal point is going to be negative 102, comma, negative 39. Questions? No? Yeah, this stuff isn't too bad, right? It's a lot easier than like the word problems and some of the stuff we were doing before, right? That's why I kind of like it at the end of Math 127, because I feel like it's a nice little break at the end. Okay. Does anybody need me to wait to go to the next page? Okay. So some other operations we can do on vectors would be we can add or subtract vectors. So if we have, so I should say actually, so if we have vector v, say, is equal to a comma, a1 comma b1, or a1i plus b1j, right? Either one of those. And say vector w was equal to a2 comma b2, or we could write it as, not b, a2i plus b2j. Then we could add or subtract our two vectors. So then vector v plus or minus vector w. So it depends whether we have an addition or subtraction. We're going to do the same thing. Basically, we're just going to add or subtract the components. So it's going to be a1 plus or minus a2, comma, b1 plus or minus b2. We would do the same thing if we are writing it in the component form or in the ij form, or it would be a1 plus or minus a2i plus b1 plus or minus b2j. And we're going to do examples here in a minute. I just want to write, besides adding or subtracting vectors, we can also multiply a vector by a constant. So multiply a vector by a constant. So C times the vector v is going to be CA, comma, CB. Or in component form, or in IJ form, it would be CAI plus CBJ. So you're just basically multiplying through by a constant. You're going to notice today that we're not going to talk about what happens if you multiply two vectors. And that's because multiplying two vectors... Oops. Oh, no, yeah, it's recording. I thought I wasn't, but, yeah, you guys can't see, but it should... Can you... Yeah, it is recording. The little timer's counting up. I don't know if you guys can see the little red timer up in the black bar at the top, but it is. No. Thank you for calling me out on it, because sometimes I do forget to start the recording again. So you can multiply a vector by a constant. You cannot multiply two vectors together. We are going to next class find out the equivalent of multiplying two vectors together, but multiplying two vectors together is not actually something that we can do. So let's try some, let's do an example here. So we're going to let the vector s be equal to -1, -2. We'll let the vector w be equal to -3, 7. Find a vector s plus vector w. So, vector s plus vector w, right? All I'm going to do is I'm going to add those pieces together. So we're going to have -1 plus -3, comma, -2 plus 7. So that's just going to give us -4, 5. Sure. Yeah, let me know when you're ready for me to go on. So it's a -1 plus a -3, right? So I think of it like you're going down 1 and then you're going down 3 more. So that's going to give you -4. Does that help? Oh, yeah, no problem. Okay, so B, let's look at if I had 3W. So 3W is just going to be 3 times each of the pieces in W, right? So it's going to be 3 times -3, comma, 3 times 7. So that should be -9, 21. Questions on part B? No. Okay, part C. How about W minus 2S? Okay, so here, I first have to figure out what 2s is, right? So I'm just going to write w. So w is -3, 7, and then I'm trying to subtract off 2 times s. So 2 times -1, 2 times -2. So we're talking about looking at negative 3 comma 7 minus negative 2 comma negative 4. So we have negative 3 minus negative 2, comma, 7 minus negative 4. So that's going to be negative 3 plus 2, so negative 1. And then 7 plus 4 is 11. So negative 1 comma 11. Questions? No? Okay. Does anybody need me to wait before I go to the next page? No? Okay. So let's try another one here. So let W be equal to 4I plus J, and R be equal to, vector R be equal to negative 12I minus 5J. Find A 6W minus 4R. So we have to take 6 times W, and then we have to subtract off 4 times R. So before we could do the problem, we first need to find 6 times W and minus 4 times R. So this is going to be 6 times the vector 4I plus J minus 4 times the vector minus 12I minus 5J. So in some ways this kind of just works like an algebra equation, or simplifying an algebraic expression. So 6 times 4 would give us the 24I plus 6J. And then I just multiply the negative through with the 4, so you would have plus 48I plus 20J. And so if I put the I parts together, I have 24 plus 48, so that's going to be 72I. And I have 6 plus 20 on the J, so 26J. Questions? Okay, so B, the length of W plus R. So before I can find the length of W plus R, I first need to find W plus R. So W plus R is going to be 4 plus negative 12I plus 1 plus negative 5J. So I'm just adding those two vectors together. 4 plus negative 12 is going to give us negative 8I. And 1 plus negative 5 is going to give me minus 4J. So questions on how I found W plus R. Okay. Sure. So remember, it's just like as if we had the components, right? When we were doing it with the component parts, we just added the two pieces, right? So here's my I parts. I had a 4 plus a negative 12. So 4 plus negative 12, that's the first part. So that's all the stuff times I. 4 plus negative 12 is negative 8. And then the J parts, here there's a 1, right? It's not written, but there's a 1 here in front of the J. So I have 1 minus plus a negative 5. So 1 plus negative 5 would give me negative 4. And that's the J part. Does that help? Yeah, there have been a lot of different things so far today. Ooh, excuse me. Does that help for anybody else that was confused? Thank you. No problem. Okay, so now I found the vector, so now I have to find the length of it, right? So the length of W plus R is going to be the square root of negative 8 squared plus negative 4 squared. Right? So it's going to be the square root of 64 plus 16, or the square root of 80. Questions? No. Okay. So why don't I will double check to see what homework is due next week, but I'll make sure that it only covers like what we've gone up to. If I didn't finish everything for what's due next week, I'll just push next week's homework forward. But so we'll stop there with material, right, for the day.